The universal expansion joint is particularly well adapted to the absorption of lateral deflection. This design may also be used to absorb axial movement, angular rotation, or any combination of these three. A common application of the universal expansion joint is to incorporate tied rod assembly in a 90-degree piping offset. These tie rods can be adjusted to prevent external axial movement. This animation shows a tied universal expansion joint used to absorb lateral deflection in a single plane Z-bend. Where dimensionally feasible, the expansion joint should be designed to fill the entire offset leg so that its expansion is absorbed within the tie rods as axial movement. The tie rod should be extended to the elbow center line when practical. The thermal movement of the horizontal lines is absorbed as a lateral deflection by the expansion joint. This animation shows a typical application of a tied universal expansion joint in a three-plane Z-bend. Since the universal can absorb lateral deflection in any direction, the two horizontal piping legs may lie at any angle in the horizontal plane. Both anchors are intermediate anchors since the pressure loading is absorbed by the tie rods. Only directional guiding is required since the compressive load of the pipe consists only of the force necessary to deflect the expansion joint. Any thermal expansion of the offset leg external to the tie rods, such as that of the elbows at either end, must be absorbed by bending of the horizontal pipe legs. Provision should be made in the design of the guides to allow for both this deflection and the reduced length of the expansion joint in its deflected position. In addition, particularly in the case of the long universal expansion joints under high pressure, additional allowance may be necessary to compensate for stretching of the tie rods under load. In cases where a universal expansion joint must absorb axial movement other than its own thermal growth, it cannot function as a tied expansion joint and must be used in combination with main anchors to absorb pressure loading. The relative expansion between the two vessels results in both axial movement and lateral deflection of the expansion joint. Both vessels must be designed to absorb main anchor loading. Control rods or pantographic linkages may be used to distribute the movement between the bellows and control their movements.